Good morning and welcome. I'm Jane Platt with NASA's Jet Propulsion Laboratory in Pasadena, California. In less than a week, NASA's Dawn spacecraft will arrive at the dwarf planet Ceres. I'd like to start out by introducing the three speakers who will be telling you more about this historic mission this morning. Joining us from NASA headquarters in Washington will be Jim Green, and he is the director of NASA's Planetary Science Division. We will hear from two speakers here at JPL as well, and they are Robert Mace, the Dawn project manager, and Carol Raymond, the Dawn deputy principal investigator. But before we get started, I'd like to introduce our JPL director, Dr. Charles Alachi, who will make some very brief opening remarks.
Good morning. This is a very exciting week in our quest of exploration and discovery. By the end of this week, as it was mentioned, Dawn will arrive to Ceres, the first mission ever to investigate a dwarf planet. It will not only visit, but we're planning to move in and stay and explore that object for a year, and beyond that, we'll stay for a long time around it. Here in the room, there are several Dawn team members. Some have worked on this mission for more than a decade, and some are relatively new, or this is their first mission, space mission. They all should be very proud of this amazing, accomplishment. In addition of being the first mission to orbit a dwarf planet, Dawn represents the first time a spacecraft actually went to two alien objects. We had Vesta a few years ago, and now we're getting to Ceres. This was made possible by a unique propulsion system called electric propulsion system. Of course, we are very excited to arrive at Ceres, so we can unravel the mystery of the bright spots that you see in the pictures, as well as many other features that will be described to you in this presentation later. Every time we visit a new object, be it a planet or a satellite, we are always surprised. And we're looking forward for more surprises that we are going to find as we are exploring Ceres. This morning you'll be seeing images, new images and rotation movies of Ceres presented by the speakers. Dawn is one of almost 20 missions then managed by JPL that are exploring the solar system and beyond. We are out there to answer fundamental questions about how our solar system originated and changed over time. So now please join me in welcoming Jim Green, the Director of Planetary Science at NASA headquarters.
Good morning. I am just delighted that Dawn is now right on the doorstep of Ceres. Dawn is part of our what we call Discovery program. It's one of many missions that are principal investigator led. The principal investigator on Dawn is Chris Russell from UCLA. And Chris has put together a fabulous team, both national scientists but also international team members and instruments. Dawn is just a tremendously exciting spacecraft and very unique. As Charles mentioned, it has ion engines, and it's the only one that we've ever launched to be able to orbit two bodies, and in this case, Vesta and Ceres. Dawn is, as its name, is not an acronym, which is most unusual here at NASA. Dawn really refers to what the mission is all about, and that is going back in time, visiting the basic remnants of objects that come together to form our planets. And so Jupiter's kept these pieces apart. It's allowed us now to get to them, and we're going to be able to be really excited about visiting Ceres and putting that in context with what we know about Vesta and the other asteroids. So without further ado, let me turn it over to Robert Mace, who's going to talk to us about how Dawn is going to accomplish getting in orbit. Bob?
All right, well, thank you, Jim. So good morning, my name is Bob Mays, and I'm excited to be here today to tell you about one of the coolest missions to one of the last unexplored worlds in the solar system. Beyond the orbit of Mars, but before you get to Jupiter, is the main asteroid belt and a planet you probably never heard of, named Ceres. It was discovered in 1801, and for many years it was considered a planet. Later it was called an asteroid, and more recently it was classified as a dwarf planet. And while it may be labeled as a dwarf, at 600 miles across, it's the giant of the main asteroid belt. Behind me is one of the best images that we have of this mysterious world. This was taken just a few days ago with the Dawn spacecraft. Now, Dawn's mission is to explore this icy world. We launched back in 2007, and for the last 7.5 years, we've been traveling to get to Ceres. And later this week, we'll be captured into orbit and become the first mission to reach a dwarf planet. The capture will occur early on the morning, Friday, March the 6th, about 4:20 a.m. local time. Now, the capture itself will occur at a time when the spacecraft is not communicating with the Earth, but several hours later, the spacecraft will send a signal, and the deep space network of ground antennas will receive that signal and confirm that indeed Dawn has captured into orbit. So today, I'll give you a little background on Dawn and tell you how we got here, and then Carol Raymond will show you some of the latest images, describe the science and what we hope to learn at Ceres. Now, to get there is no small feat. Ceres is about 3 times farther from the sun than the Earth is. So to capture enough energy at those great distances, Dawn has these tremendously long solar arrays. The wingspan is about 65 feet from tip to tip. It's about the distance from pitcher's mound to home plate on a professional baseball diamond. That makes Dawn, at the time, the largest interplanetary spacecraft that NASA had launched. And our journey is made possible by ion propulsion. Now, this advanced sounding technology has actually been around in concept for decades. You've probably heard it in science fiction, and Star Wars, and Star Trek. And while we're deeply saddened at the loss of one of our favorite actors, it was Mr. Spock who pointed out the alien ship with the advanced ion propulsion technology that was far more advanced than anything that they had on the Enterprise. So as we roll the first animation, you'll see that this hyper-efficient ion engine emits a really cool blue glow. This is due to the xenon gas that's used as a propellant. The atoms are ionized and accelerated out the thruster at extremely high velocities. Now, the ion engines produce very low thrust, about as much as this piece of paper pushing down on my hand, which, to put it in terms that we can relate to, we go from 0 to 60 in about 4 days. However, ion engines are about 10 times more efficient than conventional chemical systems, and we can continue to thrust and accelerate for days and weeks and months, or as Dawn has now for more than 5 years, to generate tremendous velocities. So with the 1,000 pounds of xenon propellant that was loaded on board, Dawn has already accomplished more than 24,000 miles per hour of velocity change. Now, to put that in context, that's more than it takes to get a vehicle from the surface of the Earth up to the International Space Station. This ion propulsion enables us to do things and go places that would be either extremely expensive or completely impossible to do. So Dawn really capitalizes on this innovative technology to deliver big science on a small budget. So now Dawn and Ceres are each traveling around the sun at thousands of miles per hour, but relative to each other, they appear to be moving very slowly. As we roll the next video, you'll be able to see the spacecraft ease up next to Ceres and be gently captured into orbit. At its closest approach, Dawn is within about 25,000 miles of Ceres. That's about 10 times closer than the moon is to the Earth. Then over the next month, we'll reshape the orbit, and we'll get ready to begin the prime science phase. So note that the spacecraft approached on the lit side of the planet and then went over to the dark side. So we've been taking images over the last several weeks as Ceres was nicely lit up in front of us. However, we're now on the dark side, so we're going to have a blackout for about the next month until we get back over towards the lit side of the body. But then the floodgates are really going to open when we get to our first science orbit in late April. Now, if we can roll the third animation, you'll see that once the prime science campaign begins, the mission profile will alternate between taking data with all of our instruments and using the ion engine to spiral down to lower and lower orbits. Our mission designers have planned a sequence of 4 lower and lower orbits, and we'll get to our final orbit in December of this year at just 235 miles above the surface. Again, for context, that's just a little bit lower than the International Space Station orbits around the Earth. So from this vantage point, Dawn will acquire its highest detail and highest resolution images of the surface. The Prime Science campaign will last through June of 2016, which will provide enough time for Dawn to accomplish all of its scientific objectives. So to wrap up, the spacecraft's in excellent condition. The approach has gone flawlessly so far, and our outstanding team has Dawn on course and on schedule for its rendezvous with Ceres. So I'll now hand you over to Carol Raymond to explain the significance of this mysterious world that we're about to explore. Carol.
Thank you, Bob. Good morning, everybody. Wow, Ceres has really surprised us and produced, the first images have produced some really puzzling features that's gotten the team, and I think many people very excited. So in the first movie that I'm showing, this is a movie that was obtained on February 19th when the spacecraft stopped thrusting, turned its camera towards Ceres, and watched Ceres for a full 9.1 hour rotation. It has a resolution of about 4 kilometers per pixel, or about 2.2 miles per pixel. And one of the first things you notice looking at it stands out very clearly is how round Ceres is. And Ceres' roundness is one of its planetary characteristics. We also know that Ceres is much lighter than the rocky planets, and so we know it retained a lot of water and light volatile elements that were present in the solar nebula when Ceres was formed. And in this sense, it's a lot like the icy moons of the outer solar system, objects like Europa and Enceladus. And in contrast, bodies like the Moon and Vesta have melted and boiled off the water and the light elements, and leaving them dry and rocky. So as Charles and Jim mentioned, one of the prime motivations of the Dawn mission is to examine these building blocks of the planets, Vesta and Ceres, which are 2 intact protoplanets from the very dawn of the solar system. So they're literally fossils that we can investigate to really understand the processes that were going on at that time. In this image mosaic, it's a flat map made from the data that you saw in the movie. And in the initial views of Ceres, we see many strange features. We see smooth areas, some areas that are chaotically fractured, and we see craters of all sizes. The shapes and the sizes of the craters will allow us to test the hypothesis that there is a subsurface ice layer on Ceres. But of particular interest are the bright spots, which appear mainly in low latitudes and stand out against Ceres' dark surface. In the next graphic, we will focus on the 2 very bright spots. Now, suffice it to say, these spots were extremely surprising to the team, and they have been puzzling to the team and to everybody who's seen them. They show up in a 92-kilometer crater that's about 19 degrees north latitude. The spot in the center is about twice as bright as the spot on the side of the crater. And as yet, it has not been resolved, meaning it's smaller than the 4-kilometer pixel size. But its apparent brightness is already off scale. It's consistent with highly reflective materials, which may contain ice or salts. This extreme brightness was really unexpected, but in 2014 it was reported that the European Space Agency's Herschel Space Observatory had detected water vapor around Ceres coming from 2 longitude sectors. This crater is located in one of those longitude sectors, so it might be related to that water vapor emission. And its association with the impact crater may indicate that impact heating resulted in exposure of underlying ice, its vaporization, and perhaps we're seeing a deposit that was left behind, which is rich in material like salts. The team is really, really excited about this feature because it is unique in the solar system, and we will be revealing its true nature as we get closer and closer to the surface. So, the mystery will be solved, but it is one that's really got us on the edge of our seats. Now, in the next graphic, I'll focus on a large basin, which is outlined in the box here. This basin is about 300 kilometers across, And I focus on this because it looks rather smooth. And we expected the surface of Ceres would be smooth, especially around the equator, because we expect a subsurface ice layer. And at the temperature of Ceres' surface, ice can flow, and over time, craters can relax. So basically, they get erased. And this basin has such characteristics. It has a very faint outline of a rim. It's not as deep as we would expect for an impact crater. And it actually shows some mounds inside. It has a smooth appearance. So this may be an example of one of these relaxed basins. We also see similar shallow craters nearby. And so this may indicate a distinct, a region of distinct geologic processes. And as Don goes through his comprehensive mapping, we'll obtain the data that we need to understand what this complex structure is telling us about the subsurface. In the next movie, I wanted to turn back to Vesta and give you a couple of highlights. So this movie demonstrates the results of Don's 14-month investigation at Vesta that revealed a complex world, giant impact basins, tectonic fracturing, a diversity of surface minerals, and significantly, Don discovered hydrogen on the surface of this dry, rocky protoplanet. And the hydrogen is associated with dark, carbon-rich material, which we believe was delivered to the surface of Vesta by impacts of wet, volatile-rich asteroids, asteroids like Ceres. So if these asteroids were delivering volatiles to Vesta, they also were delivering the water to the inner planets, including the Earth. And this is one of the connections that we want to make with the Dawn mission. In the next video, this demonstrates a flyover of the 68-kilometer Marcha crater on Vesta, where we saw evidence of gases escaping from the center of the crater, leaving these telltale pits. And the gas, likely water vapor, was released by impact shock heating, releasing that the water from the dark material that was buried in the subsurface. Our exploration of Ceres is going to yield a similar detailed data set from which we will be able to answer the many questions that are being raised by the images we're seeing today. So my last graphic is another movie which is showing, has been enhanced to show the surface relief. And over the course of 16 months, Dawn will collect comprehensive data sets on Ceres, revealing its shape, surface features, the mineralogy and elemental composition, whether the surface is active today, and how Ceres formed. So we can understand what role building blocks like Ceres had in forming our planetary neighborhood. It's clear that discoveries lie ahead, as Ceres will be revealed in stunning detail, just like Vesta. So now I'll turn it back to Jane for questions.
All right, thank you, Carol and Bob and Jim and Charles. We're going to take questions both from the auditorium here at JPL and via the phone lines, reporters who are in various locations. Do we have a question here at JPL to start things off? If so, please raise your hand and wait for the mic to come to you. And when you get the mic, state your name and your media affiliation. So while we're, okay, let's get a mic over here. And I should mention that if you're on the phone and you would like to ask a question, please press *1 so the operator can get you into the queue. Let's go to Alicia.
Alicia Chang from AP. Robert, can you give more details about Friday's timeline? When do you expect to get a signal, and do you expect any kind of dramatic moment during the orbit capture? Thanks.
All right. So the question is, when will we get the signal, and what will the moment be like? So as I described, the capture event itself is going to occur at a time when the spacecraft's not in communication with the Earth. And so there will be literally nothing to watch at the time that it happens. And so there won't be the type of dramatic mission control room event that you've perhaps seen on some other missions. And so what will happen is later in the day, later that morning, we'll have a track with the Deep Space Network. The signal will come back, and so around early afternoon is when we'll get the confirmation of signal, and really that'll be the time at which we can say, indeed, capture has occurred at the previous time.
Okay, we have a question here in the second row.
Thank you. Hi, Rod Pyle from Space.com. Excuse me. I hate to ask you to speculate, but what kind of geological activity do you think we might expect, and how much of that would be due to tidal forces as opposed to other things?
So, first of all, we don't. There aren't strong tidal forces affecting Ceres, but Ceres is much closer to the Sun than the Jupiter moons, or the moons of the outer solar system. So, the main energy source is solar. What kind of activity or processes that we would expect is, as I mentioned before, that the ice may be have an ability to flow because it's warmer than the icy moons, and there is a possibility that there is some convection within the ice layer that can be bringing material up from the rocky core to the surface. So we are looking for evidence of material on the surface which appears to have originated at the water rock boundary, that because we expect there was a subsurface ocean early on in Ceres. And so those are the types of things we're looking for, and any kind of cracking of the surface which might indicate that there's some communication between the subsurface and the surface.
All right, we're going to take a question from the phone lines right now. This one comes from Mike Wall at Space.com. Mike?
Oh yeah, hi guys. Thank you for doing this. This is really exciting for all of us. We're finally going to get a look at Ceres. And yeah, I mean, you mentioned, Carol, that there were plumes kind of observed on Ceres. And yeah, I mean, do you guys have any plans to actually investigate those plumes or try to confirm them further? Can Dawn actually confirm if there are plumes, or if those plumes were the result of just like a meteorite impact? So what are your plans going forward with that during your time in orbit around Ceres?
Yeah, so first of all, what Herschel saw doesn't necessarily indicate there are plumes. In fact, the rate of water vapor emission they inferred was very low. So if anything, there would be very faint jets coming from the surface if they are localized. Dawn's instrumentation is not meant to look for these kinds of features or transient phenomenon, but we are using our payload in to do the best job we can to look for them. So we will be making observations in forward scattered light to look for dust that's been levitated from the surface by gas emission, and of course we can use our IR spectrometer to look for water vapor in a tenuous atmosphere around Ceres. So we will be making those measurements as we get into our first science orbit late in April.
Okay, our next question from the phone lines is from Alan Boyle at NBC News. Good morning, Alan.
Good morning. I think this is probably for Carol. I wanted to ask about the bright spots. It looks as if there's a reflection that comes straight into Ceres' camera on the edge, and so I guess that's reflected sunlight, but is there any reason, have you figured out the geometry for that? It sounds as if there really won't be any observations when Ceres is on the dark side, so should our expectation be that there really won't be any imagery until sometime in April? Thank you.
Yeah, that's correct. We're not going to be getting any new data until we emerge from this trip around the dark side of Ceres. So as we get into our first science orbit, the RC3 orbit, we will be getting better resolution, and in addition, we're working on the correction to the image data to make sure that we're taking into account how the geometry affects how we see things on the surface. So we're still in early stages of even having a very accurate picture of what the reflective characteristics are.
All right, our next question, also by phone line, is from Alexander Whitsey at Nature.
Great, thanks for taking my question. It's also for Carol Raymond. I wanted to ask specifically about the possibility of cryovolcanism in these bright spots. The press release from last week suggested that volcanic processes might be at play. Can you just describe what that cryovolcanism might look like and how it would differ from, for instance, exposing ice from a meteorite impact?
So a cryovolcano would likely result in a constructional feature. So we would expect to see, a mounded feature on the surface, some sort of deposit around a central vent or a crack. And in the case of this crater, what we can say is that the brightest spot is not associated with a positive relief feature, i.e., a mound or a peak. So it's not a cryovolcano or that kind of a mechanism is not at the top of the list for that feature.
Okay, we do have more questions from the phone. We'll get to those in just a second. But again, if anybody here at JPL does have a question, just raise your hand and we'll get a mic over to you. Right now we're going to go to a phone question, and that is from Robert Holtz at Wall Street Journal.
Hi, thank you for making time for all this. I wonder if you could review the background for me on two issues. One, what's the current state of the evidence for subsurface ice and the thought that there was at one time a primordial ocean?
The shape,
question mark. Okay. For Carol, I think.
Yeah, we knew before Dawn arrived at Ceres from its shape, which was determined by Hubble Space Telescope data, and the density of Ceres that, so we know Ceres retained a lot of volatiles, as I mentioned, and its shape is consistent with a differentiation into a rocky core and an ice mantle. And if you model the evolution of Ceres from its accretion through to the present day, due to moderate amount of heat-producing radioactive elements, it's inevitable that that ice would have formed, would have existed as an ocean at some time in the past. So we do expect that in the past there was ocean in contact with the rock beneath an ice cap, and that at present it's an ice layer which is beneath a crust of infalls and dust and clays and lag deposit from sublimation.
Okay, another question from the phone lines, and this one is from Irene Klotz at Discover.
Thanks, Jane. I have two questions. The first one is for Carol. These conditions that you're describing are, I'm just wondering if they have any astrobiological impacts. Is Ceres considered a place where microbial life might have developed? And I have a follow-up.
Yeah, the answer is yes. As I said, Ceres is a lot like Europa and Enceladus. It has similar conditions in the past. At the present time, it's not expected that it has much of a liquid layer, if at all. But certainly in the past, its conditions were very similar. And so we do expect that it had astrobiological potential.
Thank you. And one other science question is, with the New Horizons mission to Pluto going to be happening in a few months from now as well, I'm just wondering if you might be able to give us some context for understanding how to think about these primordial bodies, one obviously closer to the sun than the other, but what the relationship is between these various building blocks that are kind of left scattered throughout the solar system.
Yeah, so Pluto is assumed or is thought to be a Kuiper Belt object that originated much farther out in the solar system relative to Ceres, which we believe was formed roughly where it is now. So in that sense, Ceres, being an inhabitant of the inner solar system, was probably made of slightly different material, and its history is a little bit different. Whereas Pluto is a captured object from much farther out. However, they both are have a dark surface, a fairly primitive composition. They're rich in water and volatiles, and they're both large and have planetary characteristics. So in that sense, they are similar. But I think time is going to tell as we investigate these two objects really what their similarities and differences are.
I believe we have a question also from Jim Green.
Yeah, this is Jim Green, and just wanted to make a comment on that. Indeed, New Horizons will be flying through the Pluto system on July 14th, with the data coming back several hours later, actually in the morning on the 15th. And we're going to immediately start making comparisons. It's also a substantial body. Although Ceres is 950 or so kilometers in diameter, Pluto is more than twice that. It still is, we believe, full of volatiles, a lot of water ice, and we're eagerly waiting to see that so that we can make comparisons and see what kind of connections there may be, as Carol said.
Okay, thank you. And we've got a couple more questions on the phone lines, and we will take a few from social media as well. Let me start out, though, by going to Leo Enright on the phone from Irish TV.
Thanks very much, Jane. Indeed, thank you for all your years of helping us cover these extraordinary events. I had a couple of questions about the white dots and the Herschel results. It was my impression that the white blob seemed to be still lit right at the terminator. Was that just a trick of the eye, or does that mean something, that they were still visible when everything else was in darkness? And my other question was related to the Herschel results. Could you explain just a little bit more how close or how well you can calibrate the Herschel results? Do you think that your instruments would be able to detect that amount of water vapor in a tenuous atmosphere?
Okay, thank you. On the first question, as I said before, we're not yet at the point where we have completely calibrated data. It is somewhat surprising that you see the bright spot as it's on the terminator, but we don't know, we don't have accurate slope information, and we need more details before we can really understand the significance of that. I'll leave it at that. As far as the Herschel observations, they detected water vapor emission at 6 kilograms per second, and the team has modeled such an emission coming from a distributed area, and is confident that our observations with our infrared spectrometer at the limb of Ceres could detect such an emission if it were present. So we do have the ability to confirm that observation if that activity is still ongoing.
PI. This is Jim Green. Indeed, Herschel observations were of January of last year. Very exciting, created quite the buzz in the scientific community, and of course enhanced our anticipation of really seeing what Ceres is like. Now that may mean that Ceres is active for a very short period of time, may mean that an impact on Ceres lofted the material, and Herschel was just lucky to see it. What's really important to note is because of the ion engines that we have and our ability to get down closer to the surface of Ceres for a very long period of time, we're going to see a time evolution of activity if indeed it exists on Ceres. So another dimension that actually being there really provides us that really exciting set of observations to interpret.
Thank you, Jim. And I believe Dawn Principal Investigator Chris Russell would like to say something.
To follow up on the observations of the light at the terminator, we have followed the light curve into the terminator. The spots do get darker and then go out when the terminator is reached.
Thank you very much. Again, if anybody in the room has a question, raise your hand and we'll get a mic over to you. We will take a couple of social media questions, but first I'm going to go to Kelly Beatty, Sky and Telescope, who's on the phone with us.
Hey, thanks very much. This is a question for Bob having to do with trajectories. So eventually you'll be able to get a really accurate mass and maybe some internal structure from the orbit and the orbital tracking, but how soon will you have a reasonable estimate for the total mass, even based on this first orbit, once you turn off the engines? And as a follow-up, do you have plans to go down lower than the science orbit at some point?
Okay, thank you. So the way our navigators determine the mass is we just slowly build up knowledge over time as we continue to get closer. So already they're beginning to sense the gravity field of Ceres and beginning to refine our estimates that we had before we got there of what it is. And our estimates will just continue to improve and improve and improve, basically the closer that we get to the body. So we're already starting to refine the mass a little bit. Once we get into our first science orbit, obviously that will be a significant improvement. And then as we go to each subsequent orbit, it will improve much further from there. And so to the second part of your question, Dawn will get down to its lowest orbit. And the plan is for the spacecraft to stay there indefinitely. And that's where the mission would end. The orbit is designed such that it's stable for a very long period of time, so Dawn will actually stay in that orbit for on the order of hundreds of years.
Okay, we're going to take a question from social media via Twitter. Brianna is asking, and here's a question one or a couple of you might want to take a stab at. What has the journey been like for team members to this point?
Okay, okay, well, I'll start with that one. It's been a roller coaster ride, and it's been extremely thrilling. At the same time, it's been a very long ride. The mission began more than 15 years ago when it was conceived, it was built, it was launched. It was a very exciting moment, and we've been traveling in space now for more than 7.5 years. There's been a lot of people that have worked on the project over that time, and it's been a thrill just working with all the people along the way. Is probably one of the most exciting things about it. They've done a tremendous job. There's a lot of people that had to get it built, to get it launched, and to fly it. They all do great work, and I would say for me that's probably the most exciting part, is working with a first-rate, fantastic team that gets all of this stuff done. Carol, you may want to offer a perspective.
Jim Green has something to add, I believe.
Okay, well, I can only say that I'm sitting on the edge of my seat and have been since Dawn was launched in 2006, when I just became head of the Planetary Science Division. So it's just been a tremendously exciting journey. Everything about it, from the ion engines and how they worked, and how the team has really done a remarkable job overcoming the engineering challenges that happen along the way. Anomalies do occur. And now we're right at that stage of getting captured in orbit and seeing a brand new world for the first time. So this is just really an important part of planetary science. They're going to uncover some fabulous things for us to be able to think about, and we'll have some answers right away, and it'll take maybe years before we actually figure out the puzzle of how Dawn and of course Vesta fit into the building blocks of our solar system. Just an exciting 6 or 7 years now.
Thank you. And our next question is from Ken Kramer, America Space, and he's on the phone.
Hi, thanks for taking my question, and good luck to everybody. It is very exciting. So my question is, from the data that you have so far, from the images you have so far, I wonder if you see any surface changes or any changes in these bright spots. And I'm also wondering why if you can speculate, why are these bright spots only inside the craters, not outside? And will you be looking for plumes with the cameras, not just with the IR? Thank you.
Okay, so first off, we have not seen any changes in the images that we've taken thus far. The very bright spots, as I discussed, are located inside of a crater, but there are other bright regions or bright spots on Vesta which show rayed structures emanating from a central crater, and some spots that may not be related directly to a crater. So there are other types of features which show brightness variations, but none as bright as the spots within that crater. And then as far as the last question, we are looking for, as I mentioned, any dust levitating from the surface, which would have been lifted by gases coming out of Ceres. And so we are looking for those with the camera.
We're going to take another social media question from Twitter. Space References has a question that I believe has not been touched on yet today. How is the hypothesis that Ceres has a very thin atmosphere doing? Too early to find out more about this?
Well, what I was discussing about the Herschel results is the first confirmation of the hypothesis of a tenuous atmosphere, which was made a decade earlier based on some International Ultraviolet Explorer results, where some water vapor emission was detected, at least tenuously. So I think the hypothesis is still very much on the table, and obviously we're keen to see if we can add any information to confirm it.
Thank you. And we have a follow-up question now from Irene Klotz at Discover. Irene?
Thank you. Regarding the end of the mission, I was just wondering what the limiting commodity is. Is it funding for scientists, or if the satellite can stay in orbit for hundreds of years, what would be the end of mission? And also, if you have an overall cost of the mission, I guess from launch through the nominal end of mission in 2016. Thanks.
Okay, so I'll take that one. So I'll answer the second question first, which is the Dawn life cycle cost, and that's all the way from the beginning of the project through launch all the way to the end of the mission, is about $473 million, which, as Jim described earlier, as part of the Discovery program, it's a low-cost mission. So the question about the orbit, the thing that will end Dawn's lifetime will likely be the amount of hydrazine that we have in the tanks, which we use for attitude control or for pointing the spacecraft. We use it all of the time to point the spacecraft towards the planet so that we can take images, to point it back to Earth so that we can relay all that data back down to Earth. We've got plenty of hydrazine to get us through our prime mission. However, that's the resource that we're probably the most scarce on in an extended mission kind of time frame. So Dawn will probably last for several months after the end of the prime mission, but we don't have the likely prospect of years and years of exploration in front of us.
Yes, this is Jim Green, and indeed, as Bob mentions, we have to get through our prime mission. The hydrazine is the most precious commodity, and it'll be in orbit at least the year. Then we'll take stock at how much is left, what are the new questions we need to answer, and whether Dawn is in a position to answer it. And then we would go through a process of that evaluation and then give them the go-ahead. But it would have been wonderful if indeed it had plenty of hydrazine and would have lasted for 2 or 3 years. And that, of course, is dependent upon what it would observe. But I'm sure it will observe some really exciting things. We want to see if this body is active, if this dwarf planet is actually goes through a period of time where it does emit based on impacts or anything else, and that would be of importance at that time. So we'll have to wait and see what the fuel reserves are before we make that decision.
Okay, I want to just do a quick last call, make sure I haven't missed anybody in the room here at JPL, and I believe we've taken care of all the callers on the phone. So let's wrap up with one final question from social media. This one came in via Ustream. And this is, what elements in this hypothetical subsurface ocean would allow any water not to freeze? Something like ammonia or salt, for example?
Yeah, salt would be the most likely element. Ammonia is less likely, so the main constituent would be salt.
Okay, thank you. And with that, I'd like to thank all our speakers today and everybody who came out. Reminder that all the visuals you saw today during the news conference will be replayed right afterwards on NASA TV, and they are also available at www.nasa.gov/dawn. In addition, this news conference will be replayed on NASA TV and online at www.ustream.tv/NASA JPL2. Thanks everybody for joining us today.